Hey guys, so we are going to move away from the imaginary number temporarily, learn a new skill or a new couple of skills, and then on the next lesson we'll get back around to imaginary numbers again, but they kind of all tie together eventually. Um, so this is going to be a two-part lesson. Today we are simplifying roots and rationalizing denominators. Now, in the previous lesson we talked about rationalizing when there was an imaginary number in the denominator. Here, there's going to be a radical or a square root in the denominator, so it's also called rationalizing. But before that, let's talk simplifying. Now, roots are generally, all up to this point, as far as you've had to deal with them in arithmetic and basic math and basic algebra and things, even geometry, either you could simplify a root or you couldn't. So if you have a perfect square, like square root of 100, the answer is 10. 64 is a perfect square. The square root of 64 is 8. Same thing with 25. Square root of 25 is 5. Square root of 9 is 3. So if there's perfect square numbers and you're asked to take the square root, you just get an answer, and that's all there is to it. On the other hand, if you don't have perfect squares, what's the square root of 5? Well, you either grab a calculator, type it in, and get 2 point something something something, and you have to round off, or you just call it square root of 5. You say it's not something you can simplify. It is what it is. Same thing for square root of 21. Square root of 21 is just square root of 21. Unless you grab a calculator, then it's 4 point whatever, I don't know. But that's the main thrust of it right there. Either you can simplify them or you can't. But then you get to square roots that are kind of in between. Now 12 is not a square number. So you can't just take the square root of 12 and say, oh, it's blah. You could grab a calculator and get a decimal. We want to stay away from that. We're not doing decimal rounded approximations right now. We're talking about simplifying. Turns out that 12 is, even though it's not a perfect square, it is the type of square root that can still simplify in a way. And there's two ways to explain it. I'm going to explain it both ways on this example. When I get to my problems down here, I'll do a couple of them both ways, and then I'll just stick with one method from there on out. Okay, so here's one way to look at the square root of 12. You can say, well, you can't square root 12. However, 12 is 4 times 3. That's just a fact that I know. So the square root of 12 is the same thing as the square root of 4 times 3, which can be broken into the square root of 4 times the square root of 3. It's okay to take two factors and split them up like this. Totally legit. Now, can you simplify this? Well, you can simplify this part. 4 is a perfect square. So the square root of 4 is 2. Can you square root 3? No, 3 is not a perfect square, so that just remains radical or square root. So the simplified version of the square root of 12 is 2 square root of 3. Part of it does simplify, part of it doesn't. The part that simplifies no longer has a square root over it. The part that doesn't simplify does have a square root over it. So I said I was going to do this two ways. That's one way to do it. This is the quickest way to do it if you're really, if you know your times tables and you can think of it this way. Sometimes you get higher numbers where you can't just process it. So there's another method that works. For this method, you make a factor tree. So the square root of 12 is 2 times 6. Not square root, sorry. 12 is 2 times 6. 6 is 2 times 3. So we break down 12 into 2 times 2 times 3. Now 2 times 2, that's a pair of 2's. That can be written as 2 squared. 3, on the other hand, just remains a 3. And then you say, okay, what does a square root do to a square? And the answer is they cancel each other out. Well, if the square root cancels out that square, that means you can simplify out a 2. On the other hand, this 3 does not have a square, so that's going to remain under the square root bar, or a radical, as it's sometimes called. And so you end up with this answer, which of course is the same as the answer we got up here. Most people don't like doing it this way until you get to really big numbers. If you have a small number like 12 and you can just break it down into your head like 4 times 3, then great, that's easy. Why do a whole factor tree? On the other hand, instead of 12, if this was like 120, you might want to break it down into a large factor tree so you can look at it better. This other method also brings up a way that it's taught in a lot of schools. Some call it square root prison or freeing the prisoner, something like that. And it's kind of morbid. I don't really like to do it. I'll repeat it just in case it's something you've heard before. It's something that makes sense to you. So you still do this whole factor tree thing. And then you say, okay, so, all right, the 12 is like a prison, or the square root's a prison, and the 12 is the prisoners. Well, actually, it's the, the 2, and the 3 that are prisoners. And they want to get out of prison. They want to escape. The only way to escape is if any prisoner has a friend. So 2 squared means there's 2 2's there. There's the 2 and his friend, another 2. And so they help each other escape. Here's the morbid part. But in the process, one of them gets shot. So 1 2 escapes. The other 2 get shot. The 3 that didn't have a friend is stuck in prison. And so you get 2 square root of 3 is your answer. So if you've heard that, great. I don't put myself behind that. I just don't enjoy talking about, in school, oh, someone got shot, even if it's just a silly story. So whatever. All right, so we're going to be doing that. Then again, we're going to get to rationalizing denominators. So in the previous lesson, I said you're not allowed to ever have I in the bottom of a fraction. Same thing for square roots. You're never supposed to have a square root in the bottom of a fraction. So we do this process called rationalizing. With I, you multiply by I over I. Hopefully you remember that. If you haven't watched that lesson yet, go back and do it before you do this lesson. So anyway, we got square root of 3 in the bottom. You're not supposed to have a square root in the bottom. So instead of multiplying by I over I, we multiply by square root of 3 over square root of 3. And this is called rationalizing. Now on top, when you have 5 times the square root of 3, it just stays 5 square root of 3, or 5 radical 3. It's the radical symbol. So the square root symbol is called the radical symbol. You can say it either way, 5 square root of 3 or 5 radical 3. On the bottom, square root of 3 times square root of 3 becomes square root of 9, right? 3 times 3 is 9. But 9 is a perfect square. And when you use this process, you always get a perfect square. So what's the square root of 9? 3. And we end up with this as our final answer, 5 square root of 3 over 3. You might look at this and say, hey, what about reducing? I can reduce 3 over 3. Actually, you can't. You can't reduce a radical number with a non-radical number. So a square root with a non-square root, don't reduce. You're not allowed to do that. You could reduce it if they were both non-radical, obviously. Sorry, I'm getting confused here. If you had 3 over 3, that would reduce. Or if you had square root of 3 over square root of 3, that would reduce. But when you have a radical and then a non-radical, they don't reduce. So anyway, that's your answer. So we're going to be doing some of those. All right, let's get on with the show here. So number 2, again, I'll do the evens, you do the odds. I'm going to do this 2 ways. So first, you just think about the number 8. What can you break 8 down into? How about 4 times 2? And then if you square root 4, square root 2, when you square root 4, you get 2. Square root 2, you can't simplify it. So there's your answer. The other way to do it is to make the factor tree out of 8. That's 2 times 4, and that's 2 times 2. And you say, okay, there's a pair of 2's. So I've got 1 pair of 2's. Then I have an extra 2 without a partner. The square root and the square cancel each other out. So I can simplify 1 2, but the other 2 will not simplify. It stays in the root. So same answer, 2 different ways of doing it. And it better be right. If I did it twice, yeah. All right, let's look at number 4. Same thing. Think about the number 75. Can you think of any way to break it down? Well, if you deal with money, pennies, quarters, nickels, dimes. Anyway, 75 cents is 25 cents times 3, right? 3 quarters. Square root of 25 is 5. Square root of 3 you can't do. There's your answer. Or let's do the factor tree method. This is 3 times 25, and this is 5 times 5. You got a pair of 5s, so that's 5 squared. You don't have a pair of 3s, that's just a regular 3. The square root and the square simplify, gives you just 5. The square root and the 3 do not simplify, so it stays a square root. Same answer both ways. Number 4. And there it is. Okay, I think I'm going to just stick with the tree method from now on. Because look at this. This is a big number. It's going to be a pain. I can't just think about that and say, oh, I can divide this by blah, blah, blah. So I can look at it and say, oh, it's an even number. So I can divide out a 2. and that's going to be 243. And now 243, I don't know. Let me grab a calculator. What's so special about 243? It's not even. I can't divide it by 2. 243 divided by 3. 81, okay. So I can break this down into 3 and 81. 81, I know, is 9 times 9, 3 times 3, 3 times 3. All right, this is fairly complex, but it's not so bad. Here's a pair of 3s. Here's another pair of 3s. Here's a 3 without a partner, and here's a 2 without a partner. So both of the 3s that are squared, you can square root, and both of them will simplify out of the radical. The other 3 and 2 stay in the radical. And then finally you can combine it. So 3 times 3 is 9, 3 times 2 is 6. 9 squared is 6 should be the answer. So look at number 6. 9 squared is 6. All right, let's do number 8. Factor tree. So 50 is 5 times 10, and 10 is 5 times 2. I got a pair of 5s there. So that's 5 squared. I do not have a partner with the 2, so I'll just leave that at 2. The square root and the square cancel out, gives me 5. The 2 does not have a way to cancel out or simplify, so it stays radical. Number 8 should be 5 radical 2. There it is. I don't think I'm going to need the calculator on any more problems. I'm going to get rid of that and just keep on going. Okay, number 10. Now, number 10 is a little different because it already has a number out there. It's really not going to affect anything. Let me show you. So let's just focus on the radical part. Square root of 125. Well, you know, anything that ends in 5, you can divide by 5, and that works out to be 25. Of course, that's 5 times 5. We do have a pair of 5s there. So I'm just going to bring over the negative 8, and then I got 5 squared and an extra 5. So the 1 with a square will simplify. The negative 8 is already there, and I'm going to simplify out the 5 to sort of go with it. The other 5 doesn't have a square, so it's going to remain in the radical. Oh, that's a funny looking 5. So in the end, I end up with negative 8 times 5, radical 5. Well, that's just negative 40, radical 5. And there's that. There we go. And that's it for simplifying radicals. So you need to do the odds, of course. Look at my examples as you do those. It should come along fairly well. Now we're into rationalizing. So this is where we have a radical in the bottom of a fraction, and it's not allowed to be there. So just like rationalizing imaginary numbers, where you multiply by I over I, we're going to multiply by, well, whatever that is. So we multiply by square root of 2 over square root of 2. On top, we have 5 times square root of 2. That's just 5 square root of 2. If they were both radical, I could multiply them and get 10. 5 times 2 is 10. But if they're not both radical, you can't do it. So there it is. Now here, square root of 2 times square root of 2, they are both radical. You can make it square root of 4. And then just look, square root of 4. What is the square root of 4? It's 2. Can I reduce the 5 and the 2? No. Can I reduce the 2 and the 2? You might be tempted, but no. One's radical, one's not radical. So they're not compatible. You cannot reduce those. This is the answer. Number 12, 5 radical 2 over 2. Let's look at 14. Just like number 12, multiply by the denominator. On the top, 4 times square root of 5 is 4 square root of 5. Bottom, square root of 5 times square root of 5 is square root of 25. And the square root of 25 is 5. Now, I've had students over the years come up with various shortcuts for doing this, and that's great. If you figure out little tips or tricks, you find patterns that always work, so be it. I have my own shortcut, but when I try to explain it to students, it usually makes them more confused. It's one of the hazards of, well, teaching is, making kids more confused. I never want that to happen. So I'm not going to do my shortcut on any of these. All right, number 16. Now, this one's a little different because you have radical on the top and the bottom. And 2 and 3, if you could reduce those, they are compatible. You could do it, but 2 and 3 don't reduce. So we're just going to do the same process, multiply by square root of 3 over square root of 3. On the top, when we multiply them, because they're both square roots, we get square root of 6. On the bottom, you multiply them, square root of 9. The square root of 9 will reduce, or I'm sorry, simplify. Square root of 9 is 3, and that is the answer. Again, you cannot reduce the 6 and the 3 because one is radical, one is not. So they're not compatible. And you see the answer right there. A few more of these and we are done. Number 18. All right, now look. Square root of 3 over square root of 9. These are compatible. They're both radicals. That means we can reduce them before we start. 3/15, you divide them both by 3, you get square root of 1 over square root of 5. And what's the square root of 1? Well, that's easy. The square root of 1 is just 1. Now, have I solved it? Am I done? No. There's still a radical in the bottom, which you're not allowed to have. We need to rationalize this. However, what I am working with now is a lot smaller and simpler fraction than what I started with. So by reducing this before I even start the problem, I end up with a simpler problem to solve. Multiply by square root of 5 over square root of 5. Top times top is square root of 5. Bottom times bottom is square root of 25. And what's the square root of 25? You hear my dog in the background? Square root of 25 is 5. That is the answer to number 18. Radical 5 over 5. Good, good, good. How about number 20? I'm sorry, he's going nuts. All right, number 20. Same deal. We can reduce the 15 and the 20 before I start because they're both square roots. They're both radicals, if you want to use that word. So go ahead and do it. It makes it simpler. 20 over 15. Reduce them both by 5. We get square root of 4 over square root of 3. Furthermore, the square root of 4, easy. You can do that. The square root of 4 is 2 over the square root of 3. Now we can rationalize it. Multiply by square root of 3 over square root of 3. You get 2 square root of 3 on top. Bottom gives you square root of 9. And what is the square root of 9? Square root of 9 is 3. 2 square root of 3 over 3, right there. Okay, now I'm not going to redo number 20. I'm going to talk about it a little bit more. Let's play devil's advocate and start from the very beginning and say you didn't notice that these could be reduced. So you did it like every other problem, and you multiply by square root of 15 over square root of 15. Is this still going to work? The answer is yes, it will still work. You'll get square root of 300 on top, and the square root of, what's 15 times 15? 225 on the bottom. The bottom is not so bad. The square root of 225 is 15. The top, square root of 300, well, you're going to have to do the factor tree thing on it, like 10 times 30 and 5 times 2 and 6 times 5 and 2 times, do this whole thing. And basically you're going to have to simplify it like it was one of these. So eventually, after you do all this work, it'll circle around and give you that answer. It'll still give you the same right answer. It's just going to be a whole lot more work with a whole lot more steps. So it's a better policy if you can reduce the fraction before you start. Go ahead and do that. It's going to make your life easier. That being said, what about number 22? Can I reduce this? No, 3 and 50 don't reduce. So here, I am going to have to multiply by square root of 50 over square root of 50. That gives me square root of 150 on top. And on bottom, 50 times 50 is 2,500. Sorry, make that a little better. Okay. So that gives me square root of 150 over, what's the square root of 2,500? You'd be like, oh, that's too big a number. I don't know. Well, duh, it's 50. Just look back one step. Now, can you reduce these? No, one's radical, one's not. can I simplify square root of 150? That's 10 times 15, right? And that's 2 times 5, and that's 5 times 3. And I do have a pair of 5s there. So that's 5 squared, and then a 2, and then a 3. Remember, the square root and the square cancel out, so that's 5 radical 2 times 3, which is 5 radical 6. So I can make this 5 radical 6 over 50, and now 5 and 50 reduce, right? Divide them both by 5, you end up with 1 radical 6. 50 divided by 5 is 10. 1 radical 6 over 10. And then 1 radical 6, having a 1 right here, is the same thing as having like a 1x. 1x is just x, so 1 radical 6 is just radical 6. So square root of 6 over 10 ought to be the answer to number 22. And there it is. So they started a little simpler, few steps, and as we go, they get a little more difficult. Number 22 was a lot of work. Number 21 for you is going to be kind of like this one here. There's going to be a kind of a lot of work to do. So keep that in mind. All right, do this to the best of your ability. Really hope it clicks. You need to have these skills, kind of basics, going through Algebra 2 when we move into more topics. If you have any questions or difficulty, please let me know or show up to our regular Google Meet, and I will help you out as much as possible. Until I talk to you.